In Part 4 of the Unit 1 notes, we will be covering scientific notation. Scientific notation is a way of expressing numbers that are too big or too small to be conveniently written in decimal form. In chemistry, this is useful for when we are working with the number of atoms or molecules present in an object we can work with on the macro scale. Here we have an example of scientific notation. You can see the number out in front of the time sign, which is called the coefficient. We have our base, which is always 10 for us, and we have an exponent. Positive exponents are used for very large numbers, and negative exponents are used for small numbers. To determine the value of an exponent, count as you move the decimal to the right of the first non-zero digit. For large numbers, this means you are sliding the decimal to the left, which will give you a positive exponent. For small numbers, this means you are sliding the decimal to the right, which will give you a negative exponent. Here we have a couple of examples. In example 1, there's no decimal shown, so we can imagine that it would be at the very end. I need to slide it until it is right next to the 6. So I'm going to move over 1, 2, 3, 4, 5, 6, 7, 8 spaces. So now my value is 6 times 10, and that 8 is going to be my exponent. In example 2, we have a number which is much smaller than 1. So this time I need to slide my decimal to the right. I'm going to slide over 1, 2, 3, 4, 5, 6 until it is to the right of the 2. Because I was moving my decimal to the right, my exponent is going to be negative. There's another way that you can think about this. It's all about balance. As the coefficient goes up, the exponent must go down so that the number remains constant. As the exponent goes up, the coefficient must go down. So here, if we consider this value 600 million, when I'm sliding my decimal to the left, that number keeps getting smaller and smaller. So my exponent has to go up to compensate. And here, as I am making this coefficient larger by bringing my decimal to the right, my exponent must go down. This will help us a little bit later when we need to fix a number to turn it into proper scientific notation. For our checkpoint, we will be converting a whole bunch of numbers into scientific notation. Make sure that you are writing out each of these example problems within your notebook. All right, for our first number, again, there's no decimal here, so I'm going to imagine that it is just on the end. I'm going to slide it over 1, 2, 3, 4, 5, 6. So I need to keep sliding until there is only one non-zero number to the left of the decimal. This leaves me with 2.5 times 10, and because I slid my decimal over 6 spaces to the left, it is a positive 6. For my next example, I'm sliding over 1, 2, 3, 4 spaces. The negative sign remains out in front, so I have negative 7.2 times 10 to the 4th power. In number 3, I'm sliding over 1, 2, 3, 4, 5, 6, 7 spaces. So 6 times 10 to the 7th power. For number 4, we're going over 1, 2, 3, 4, 5, 6, 7 spaces. So 5.37 times 10 to the 7th power. Now our values on the right side are all less than 1. So this time we're going to be sliding our decimal the other way. My decimal needs to move over 1, 2, 3 spaces for this first example, so that I'll have one number to the left of the decimal. So 3.1 times 10, this time to the negative 3rd power. Number 6, I'm going to slide over 1, 2, 3, 4 spaces. For number 7, just like in number 2 over here, I have a negative sign, so that's just going to remain out in front. It doesn't affect my exponent. I'm going to slide my decimal over one space. 3.1 times 10, this time to the negative first power. All right, finally, number 8. I'm going to slide my decimal over 1, 2, 3, 4, 5, 6, 7 spaces. 9 times 10 to the negative 7th power. For our next set of checkpoint questions, we are going to be converting each of the numbers into proper scientific notation. These examples do not currently have one non-zero number to the left of the decimal. Something like this might occur if you try to do calculations, so addition, subtraction, or multiplication, division, with numbers that are in scientific notation out by hand. So you're not necessarily using a calculator. All right, so currently for number 1, my decimal is right here. I need to slide it over 1, 2, 3 places to the right. Now this is where that concept of balance comes into play. I made my coefficient bigger by a factor of 3 by bringing it to the right. That means my exponent needs to go down by 3. So 5 minus 3 is going to be 2. So that is my proper scientific notation. All right, next, I'm going to slide over 1, 2, 3, 4 spaces. So that's going to be 8.1 times 10. And since I made this bigger by 4, my exponent has to go down by 4. So this time is going to be to the negative 8th power. For number 3, I'm only sliding over one spot. 2.78 times 10. I made this bigger by a factor of 1, so this goes down by a factor of 1. So now it's to the 2nd power. Here we're going to slide over 1, 2, 3, 4, 5 spaces. So since this got bigger by a factor of 5, my exponent goes down by a factor of 5. So now I'm going to have to the negative 12th power. It's important that you think of this as a number line. So you don't want to take 7 minus 5. You have a negative 7 minus 5. So you're going further down. All right, on the right side, we have numbers that are all getting considerably larger instead of all the small ones that we had over here. So we're going to be sliding our decimal in the opposite direction. For this one, there's no decimal shown, so that means it's on the end. I'm going to slide over 1, 2 spaces. 2.38 times 10, and if this got smaller by a factor of 2, this time my exponent is going up by a factor of 2. So it should now be 7. In our next example, we are sliding over 2 spaces again. The negative sign is going to come out in front. This time our exponent is going to go up by 2, so it becomes 11. Number 7. Again, negative sign out in front. I am sliding over 2 places again. So negative 3.1 times 10. I have to go up by a factor of 2. But since my exponent here is a negative and I'm going up the number line, that means negative 5, not negative 9. I often have students that go in the wrong direction there. All right, our final example here, number 8, we are going to slide over 1, 2, 3 spaces, 9.2 times 10, and since we're going up by 3, that's going to be a negative 3. All right, so there may be times when you are given scientific notation, or maybe you calculate scientific notation, but you need to see that number in standard notation, or what you would consider a typical number. We can fix that by just sliding our decimal to the left or right until the exponent will become 0. So again, knowing that idea or concept of balance will really help you with these. For this first example, I need to slide my decimal 4 spaces to the left. So I'm going to rewrite this 2.0. I'm going to go over 1, 2, 3, 4. And in any of those little empty spaces, I'm going to put a 0. So for this first one, 2.0 times 10 to the 4th is equivalent to 20,000. All right, in our next example, we have 3.4, and I'm going to slide it over 6 spaces. 1, 2, 3, 4, 5, 6. I'm going to fill in my zeros. And it looks like this time we have 3,400,000. Notice I'm not just adding 6 zeros onto the end, because sliding over the decimal to the other side of the 4 actually took up one of those numbers. All right, for our next example, here we have a negative exponent, so we're going in the other direction. So I'm going to write my number a little bit further over to the right this time. I'm going to slide over 1, 2, 3. So that's where my decimal should end. Zeros are going to end here. So I have 0.005. We don't have to write the other 0 on the end. Typically, we put a 0 out in front of the decimal as well, so this is what I would write out for my final answer. All right, for number 4, we have 9.86. I need to slide my decimal over 5 spaces, so 1, 2, 3, 4, 5. I'm going to fill in zeros within those slots. So this is equal to 0.0000986. All right, that concludes our lesson on scientific notation. When we come back in part 5, we will be covering operations with scientific notation.